Okay, so we want to find how much work to lift a 20-foot chain. So 20-foot chain that weighs 60 pounds. So 60 pounds, 20 feet. So that the top end is 30 feet above the ground. So this is the ground right here. And so these are the stages. First it's coiled up. And here, this is where you're grabbing it. That's supposed to be a hand. Or maybe an arm. A machine arm. Anyways. A robot, maybe. So you start lifting it up a certain amount, but then notice that you want to lift it so that the top end is 30 feet above the ground. So that means that it's going to be, the bottom end is going to be 10 feet above the ground. So we'll talk about how to take that into account in a little bit. So first, our first task is to find the mass density. And so since it's 60 pounds and 20 feet, well then the mass density is going to be 60 pounds per 20 feet. Well, that's 3 pounds per foot. Okay, so before we continue, let me draw the chain where it's just barely leaving the ground. So this would be a 20-foot length of chain, and this is right when there's none left coiled. And then over here, of course, it's up in the air. Okay, so then once I do that, let me put the axis down here. So notice how the chain needs to travel from point 0 to a certain distance y. So that's the work needed to take the chain from the ground up to where it's going to be. Now, from this point to this point, the work needed to take this slab. So let's say this is a length of slab of delta y. So the work for this slab, this is going to be the ith slab right here, this one that I marked, is going to be 3 pounds per foot times the thickness of that slab, delta y, which of course is going to go to 0 feet, and then times the distance that it needs to go. Okay, so that distance is going to be y feet. Okay, and so then here we have that the work to take this slab from here to here is going to be 3y foot-pounds. So then the total work, and let's forget about this part right here because I'm going to explain that in a minute. To take the chain from coiled to right off the ground is going to be the integral from 0 to 20, because that's how long the chain is, of 3y dy. Okay, but then notice how once it's right here, the conditions are changed, because now what you have is that this chain, when it goes from here to here, this has a fixed force. So it's no longer changing. Now it's just traveling up. So going from 0 to 20, it's this much, but then it has to travel another 10 feet, but it's always weighs 60 pounds after that point. So then I'm just going to add the work needed to take it from here to here, which is going to be the force, which is 60, times the distance, which is 60 pounds, and then times the distance, which is 10. And this is a constant. And so then when you do this guy, we're going to get 3y squared over 2 from 0 to 20 plus 600. And so the total is 1,200 foot-pounds.